We're told the company Pinwheel Incorporated, they develop toys. It costs $1,400 to develop each toy and $35 to manufacture every single toy after they've already developed the toy. So they had to do some research and development. It costs about this much, and then it costs $35 to actually manufacture each toy. We're being asked for a linear model for the cost, C. We're going to use C as the cost for producing N toys. So first and foremost, the variables that we need to use here are cost and N toys. It's important also they've noted that we want to find a linear model, and that's good because given the information, we'd actually only be able to produce a linear model from this information. Okay, so let's first produce the linear model for the cost. They've actually given us all the information that we need here. So what we have is the cost of producing toys equals, well, first they have this $1,400 that they spend. So no matter what, even if they don't actually produce any of those toys or manufacture any of them, it's going to cost them $1,400. And then it's $35 per toy. So if you think about it, like if they made 2 toys, let's just think about 2 toys, for instance. What we'd do is we'd add on 35 times 2 to the 1,400 here, right? We'd add on 35 times 2, or multiplying each of the toys they manufacture by 2. Well, they're saying we don't want just for 2 toys. What if we produced 5 or 6? Well, I mean, let's just say something like, for instance, if we wanted to produce 6 toys, we would write it like this, 35 times 6. To generalize this for any number of toys, what we do then we find is $1,400 plus the 35 times however many toys that we make. So an actual linear model for this situation would be 1,400 plus 35n. If you think back to general linear models, this makes sense. This $1,400 is like a starting amount. We would consider that like a vertical or y-intercept. It'd actually be a c-intercept in this case. And then the 35 is the slope, meaning for every toy that you produce, the cost is going to go up by 35. And so that feels right. Now that we have our linear model, if we're asked some questions, so if we're over here, if we're asked the cost to produce 1,500 toys, or how much they could produce with 132,650, we actually can answer these pretty quickly. Again, just remember on this linear model right here, what we have is this is the number of toys. This is what we would input that information, multiply it by 35, add 1,400 to get the cost, and then a C being the cost in dollars. So to answer these questions, I won't solve the equations completely, but what we do is take this and then replace whatever variable they give us information about. So in this one, we have the cost is going to equal 1,400 plus 35 times the number of toys they produce, which is in this case 1,500. I would then evaluate this, doing the multiplication first, and then adding the 1,400 on to get the final cost. B is just the opposite. We're given a cost, so we're given that the cost is 132,650, and we need to find the number of toys, and we're just setting up here a 2-step linear equation that we can solve for n by obviously subtracting 1,400 and then dividing by the 35.